Oh, look out. Hey, folks, we got a quiz coming up here. I thought I'd go over a few problems. I'm not going to go over every single problem on the review, but I'll post a answer key with some other answers. But let's go over a couple of proofs, see how we're feeling here. This first one is pretty straightforward, so I think you can do this one on your own. But let's maybe do the second one. We'll kind of do a couple of these. Okay, so let's do this one, huh? So we got a little proof time. And here we go. We got statement and reason. We're going to write down our given. Our given is pretty straightforward as one thing. They say HJ is a perpendicular bisector. Perpendicular, remember, is that symbol. So I'm going to say perpendicular bisector of KI. All right. Now that's telling us two things. Okay. It's telling us it's a bisector, but also perpendicular. All right. So we know we get a perpendicular angle down here. So we get a right angle. And because this line has to be 180, both of these are going to be right angles. So that means that they have to be congruent. Okay. Then we can come back into our proof. And we could say angle HJK is congruent to angle HJI. Right? And you could say definition of perpendicular, you could say definition of right angles. I'm going to go for that one. I'm going to say definition of right angles because we know they both got to be right angles and two right angles are both equal to 90, so they're equal. Okay, so we're going to say definition of right angles. So we're still using the given. So we use the given to use the perpendicular to say that those are equal, but it's also a bisector. It's a perpendicular bisector of KI. KI is a side. It's not an angle. So it's splitting this side KI into two congruent pieces. All right. So we get that these are both congruent. We get KJ is congruent to IJ by definition of a bisector. Okay. And it's a segment bisector. It's splitting the segment into two pieces. Definition of a bisector. Okay, so now look at what we got. We got a side and we got an angle. So we have two things. We need three things for these things to work. Ooh, I guess there's no proof statement. I didn't put the proof statement on this question. I'm putting in the proof statement. Sorry, hold on. Okay, there's the proof statement. So we need one more thing. So we've used our given up. We've used the given. Now we got to use the picture. Okay. Looking at the picture, do these triangles share anything? What was that? Yeah, they share this HJ in the middle. So that's reflexive to itself. So we could say here, HJ is congruent to HJ. And that's going to be reflexive, okay? Good old reflexive property. Whoa, door just made a noise. Scared. Someone's outside. Look out. Okay, so now we got what we need. Now we just need to, what shortcut are we going to use? Let's write the proof statement. So we got triangle KJH is congruent to triangle IJH. That's a triangle symbol, guys. Accept it. Oh my gosh, my writing is so bad. That's an H. So what shortcut is this? Look at it. Just look at it on the thing. Side, angle, side. Side, angle, side. All right, cool. Let's do another one. God, oh, there's the proof statement. It's kind of hidden over there. I don't know if you can see that or if I'm in the way, but it says triangle ACB is congruent to triangle DCE. We got a given. The given is or angle BAC is congruent to angle DEC. So that's these angles. So let's mark that on the big board. And then we have a bisector. Okay. Look at that straight line. So we have our given. Angle BAC is congruent to angle DEC. And then, whoops, we should do a little thing here, a little bracket, because we have another given. Okay, so we marked our first given, right? So we don't have to do anything there, but we do have to do something with the bisector. So BD is bisecting AE. So AE gets split into two pieces. So we get AC and CE. So we're going to put that. We're going to say AC is congruent to, we're going to call it EC. Okay, and that's definition of a bisector. So now we got an angle and we got a side. We need one more thing. We got to use the picture now. We've used our givens up. Our givens have been used. Kian had it. Kian said it. What'd you say, Kian? Vertical angles. Nice. So we got vertical angles here. So we know those are equal. So we can say angle ACB is congruent to angle ECD. And that's vertical angles. Look at that E. What a piece of work, piece of art. Okay, now look at our picture again. Angle, side, angle. That side is in between. So we got angle, side, angle. So now we can do the proof statement. Triangle ACB. Sorry, this printing is terrible. Is congruent to triangle ECD side, or sorry, angle, side, angle. Okay. What do you think? One more? Uno más proof? Uno más proof? We've done a lot like that. I think you guys can do that. Maybe we try this one because this is interesting too. Hello, hello. So let's do it. Oh my gosh, have you seen a straighter line than that? It's like there should be like a channel that's like not ASMR, but just people drawing super straight things or super round things. What do you think about that? You know, just super straight things, very satisfying things. I guess there's a Reddit page like that. Oddly satisfying, I think is what it's called. Okay, so we got segment OM bisects angle. This is an angle bisector, kiddos. Angle bisector. Okay. So we got an angle bisector. Ooh, that bracket was terrible. And then we got angle LOM is congruent to angle NOM. Right, right, right. So let's mark that on the big board. LOM is this one right here. So we got that these two angles are congruent. Okay. Then let's use our other given. Our other given says OM bisects angle LMN. So it splits this angle on the top into two equal pieces. Okay. We got to write it out still. So we're going to say angle LMO is congruent to angle NMO by angle bisector. Okay, so we have two angles Now we need to use the picture to get something else. We need to use the picture to get something else. Do they share anything? Are there vertical angles? Is there alternate interior angles? Those are the things that might be in the picture. In this case, they share this side, MO, or let's call it OM. That's what the book called it. So we're going to say OM is congruent to OM by reflexive property. Okay, so now we got everything we need. We got three things. We got angle, side, angle. So let's use our shortcut. We're going to say triangle. Triangle now. LMO is congruent to triangle. NMO by angle, side, angle. Right? We proved the triangle is congruent. Nice job. Are we done? What? We're not done? Oh, look at what we need to prove. We need to prove these sides congruent. What can we use? It's that weird thing. CPCTC. So we're going to say ML is congruent to MN by CPCTC. That is good stuff. There's the end of the proof. Keep practicing this stuff. If you have questions, thoughts, concerns, come in before school, after school, get some help. I'm here to help. I will also post the full answers to the review sheet so you can look those over. Okay? Hopefully this is helpful, but if you have other questions, come in and I will help more. Hope you have a great rest of your day. Signing off.